Hey, g'day, it's Prezzo here and welcome back to the shop. Look what the mail lady bought me the other morning. This is a BXA quick change tool post with the wedge. She also bought me a Moore and Wright metric dial indicator, a 60-degree dovetail milling cutter. I also found in the scrap box a piece of 40mm square aluminium alloy. Now, I don't know about you, but just looking at all this stuff, I reckon this has got quick change DTI holder written all over it. The type that I'm planning to build will have an aluminium arm, which is going to be clamped into a groove, as you see here, in much the same way that you would clamp a tool holder in a normal quick change tool holder block. This arm will be slit at both ends, and there will be a clamping screw fitted so that you can, with a Allen key, just simply loosen the screw and flip the dial indicator from one end to the other. And this will allow you to indicate against a diameter or a face. Now, I had a look at what other people had done, as I'm sure you do, and I saw an excellent design, and I'll put a card so you can check it out for yourself. But the maker who did this obviously thought it through and realized that you could just simply flip this block over and then twist the indicator, and that would do the same job as what I'm planning to do by having two ends on this arm. The difference in his case was that he had sized the block so that it didn't need a height setting screw, and I will have to fit one for my lathe. I did draw out a design to fit my lathe, but the block ended up being quite large and very bulky, and it just seemed to be a waste of material. In the case of the YouTube gentleman that I was telling you about, I think he may have used an AXA style quick change tool post, which is slightly lower profile and slightly smaller. With the one that I have, it means that you do end up with very bulky tool blocks. So I'm going to give this a go. The first step, of course, is going to be to clean everything up, get everything squared up, and we'll go from there. So stay along for the ride. Okay, so let's get this stock all cleaned up. Well, that's the arm stock, reduced to 16mm thick. The drawing shows this piece to be 16 by 12, but I'm thinking just for rigidity I might make it 16 by 16. I've got plenty of stock and I've got a hole here I need to get rid of, but I'm pretty sure I can do that. Alright, so we'll get rid of this, this hole here, and we'll get this reduced down to 16mm thick. And we're going to do some milling work on the ends, get that all rounded off. So there's our arm that's going to take the stem of the indicator, so I'll need to drill both ends and actually drill two holes and radius that end, and I'm going to do all that on the CNC mill. Well, here's the tool path we're going to use. I'm just going to do a conventional milling cut at both ends and then a climb milling pass to finish, and I've got an 8mm solid carbide end mill. Run it fairly fast, and then the four holes I'm going to drill them separately later, so we'll just see how this radius operation goes first. Okay, so I've got the stock set up in the vise. I'm going to try and use the mist coolant, so you'll probably hear the compressor run a bit. So I've taken the parallels out underneath here because I just wasn't sure if they're going to jiggle around and maybe get in the way. So this vise is pretty solid, so I'm not worried about the stock moving. So let's just turn our coolant on. Well, shoot, what happened there? Okay, my vise let me down. Damn it. Okay, I'll just reset. I know what happened now. This bolt, which pulls up into the slots underneath here, just was pushed too far, and although it appeared to be holding, it just took a little bit of hook on the cutter to pull that out. So just goes to show you, doesn't it? Always make a fool of yourself on camera. Anyway, let's try again. Go through that whole process again. Oh, nothing's going well today. That looks especially ugly. I think I might have to reduce that depth of cut. This, I'm sure I've said this before, but this machine is not the most rigid thing in the world. So give me a minute to regroup and we'll try this again. Alright, just reduce the depth of cut and the feed rate, see if that makes a difference. Well, I'm not sure if you could tell, but I don't think I could have made more mistakes if I tried with this. I'm not convinced my Y offset is correct. As you can see, I've got a hard edge there instead of a nice tangent, and I think the other edge is offset. I also made it too short. When this got ejected from the vise, I misset my X origin, or my X offset, so it cut this end too short, and then when I went to do this end, it was offset too far to the left, so I had to reset my X for this end. So the whole arm's now about 3mm too short. Not that it matters, but it's just a bit of a dent in your ego when you mess up so badly. So I'm going to drill both of these holes at 7.9mm. This one's going to get reamed to 8. I'll just leave the other one because it's just a clearance hole. So I'm just going to do this with manual data input rather than writing a G-code for it. Doesn't seem worth it. The way things are going today, I'd probably stuff it up anyway. So let's just try this. Okay, well that takes care of that end, so I'm going to have to reset for the other end and do the same process, but it means resetting the X. Okay, so let's ream this one at 8. Alrighty, so I think I'm just going to leave this now and let's work on the other part of the tool holder. So I get the dovetail done and get the slot done to hold this, and then we can think about drilling our cross hole here with a clamping screw and slitting the ends. Okay, so the next part of this build is to replicate this dovetail in the aluminium alloy. This is a spare tool holder that I got for my quick change tool post, and just for fun I've already tried this in a piece of alloy, and although I thought I was being really careful in marking out and cutting the dovetail, it turned out to be just a fraction oversize, and it only just clamps up when the wedge is actually pushed into the dovetail. And my worry is that this stuff being so soft after a period of time will wear, and you just simply won't be able to clamp this up as tight as you'd like. So I do need to be a bit more careful when I'm cutting this one to make sure I get it, pretty close to tolerance. So what I'm going to do is measure this one, and I'll mark it out on here just with scribed lines, but of course when I'm milling I'm going to have to be a bit more careful in that. And I think this time I'll use the technique where I put a couple of dowel pins into the dovetail and measure the space in between. So let's go ahead and get this one marked out, and just for reference, and then we're going to mill it, but we're going to be a bit more careful. So just checking the depth of this one. That works out to 10.7. Yep, 10.7. Okay, 10.7. So that's the depth that I'll be machining to, and we're just going to get a couple of reference lines here now for the edge of the dovetail. So 80.46, 40.23 is our centre line. And we can just offset above and below that now to get a width. Now I could just turn the block over, but I'm not going to. I'm going to actually go in the positive direction, the same measurement. Alright, so there's the marking out for the dovetail. The 60-degree angle will be taken care of by the dovetail cutter. So just a bit of a sanity check, just having a look at that. I'm pretty happy with that. Okay, well all we need to do now is hog out this slot. I've already touched off in the Z and set my DRO there, so we're going 10.67 millimeters deep. Alright, that's pretty close. It's a tiny bit undersized. It'll allow me to clean it up a bit with a file later on, as the finish from that cutter is not brilliant. That's now 10.67 deep. I've got a little bit of a witness on both sides there, and when we cut the dovetail we're going to undercut the dovetail is not quite as deep as the centre. It's there's a little bit of clearance there. I don't know how much, and it doesn't really matter as long as the width between the angled shoulders of the dovetail is correct. So I'll swap out now for the dovetail cutter. Okay, well I've got the dovetail cutter in there now, and I bottomed out on the previous cut and come back up 0.1 of a millimetre. So we'll go ahead and cut this side, and we're just going to do that by eye. And it doesn't really matter if we're not precisely centered on this block, so I'm just going to eyeball it, and then when we start doing the other side, that's when we're going to measure really accurately. Well, that's close. Just looking at the flap that's left on here, it looks very similar to the other block that I've got, but I'll go a little bit closer. Alright, well I don't want to go any closer than that, so we're going to do the other side. Okay, well the nearest thing I have to a hardened dowel pin is a couple of 10mm end mills. This is a broken one, and this is just a good one. They both got 10mm diameter shanks, or in fact it doesn't really matter, they're the same, and that's all that matters. So a 0 on the caliper there. And let's just hope that I save some embarrassment here, and that this is undersize. So 0.39 undersize. Now, I'm no mathematical genius, far from it, but I believe if I just track the vise that distance, 0.39, and make a deeper cut, that should bring it to size. But I've been embarrassed before, so I'm just going to sneak up on this and we'll do a couple lighter cuts. So I'm going to zero my X, and I want to try and do a climb cut to finish, just so I get a slightly better finish. It is a bit rough in there. Alright, so what does I say? 0.39, let's go 0.1. Alright, that's 0.3, that seems to be right. So we'll go another 0.2. Please let this be undersized. Yep, 0.1. So I'm going to take 0.05 off this side as a climb pass, do the same on the other. Feels nice and smooth in there, so I'm going to do the same on the other side. It's showing 0.07 under. And I've got a suspicion I might leave it that way. Well, I'll just get the tool post and we'll try it. Alright, so I'm just going to push this in here and see how close we are. Come on. There we go. Well, that's tightening up pretty much where all my other toolbox do. So if I leave it like that, the handle is going to be in the correct relative position, and being aluminium, this is going to wear, so I'm happy with that. I'm going to leave it there. It's still got a bit of a burr on it. There we go. So that's alright. So what we need to do now is put a slot in here for the bar that we've already made. And it's not critical, so it's around about 16 millimeters wide, roughly in the center of this. Remember, we're adjustable for height here, so it doesn't really matter. So we'll go ahead and get that done. Well, I'll just deburr this first. Alright, well, this might seem like a rather crude way of doing it, but I've just marked it out with the scribing block, and I've offset the grooves by about a millimeter or two. The idea was that when I finally put this thing on the lathe, if I put the groove exactly in the center and it's not right, I can't get the correct height that I want from it, then turning it over, it's not going to make any difference. Whereas if I offset the groove, I at least have the option of turning it over the other way. So I'm going to just cut this 18 millimeters wide, even though the bar's only 16. Well, that fits, but I want to give it some clearance just so I can pack it up or down if I ever have to. So let's give it, say, a millimeter this way. That's what we want. Okay, well, I've done some marking out on this block. This is where I'm going to put the two clamping screws for the arm, and there'll be a single screw here, which would be the height adjustment. Now, most of these toolboxes have got 3 or 4 clamping screws. I'm only using 2 because in reality there's very little load on this part. If there's load on it, you're doing something wrong. But there's another reason why I'm only using 2, and you'll see that later. So these are going to be drilled M6 just for 2 screws, and this is the arm, which will have a clamping screw to clamp down on the 8mm spigot on the gauge. So that's also going to be M6. So I've got a number 7 drill bit here. That's a number size, and that's the tapping size for M6. So I'll go ahead and drill these holes. then after I've slit this, I'll open up the top, and that'll be a clearance size for an M6 screw, and I might counterbore that a little as well. So I'll just pilot drill this one here while I'm here. Now, according to the other tool blocks that I have, that's M10, but it's a very fine 10mm thread, and I'm not sure I've got one, so I'm just going to check. If I don't have an isometric fine, we're just going to have to use the 1.5mm pitch, I think. Yeah, well, I just did check, and I've got nothing in isometric fine, so we're just going to have to make do with the 10mm by 1.5 pitch. And in reality, this is going to be a set and forget type of thing, so I don't know if we need a really metric fine thread or need a metric fine thread. So I'm guessing this is going to be okay. So this is 8.5mm metric. Yeah, I was holding that rather awkwardly so you could see what I was doing, and I could feel it was going to grab, so you almost got to see a nasty accident. The slitting saw that I was going to use to do this was too small. The diameter wouldn't have reached this second hole here. So I swapped it out for a 4-inch, I think it's a 4-inch, 3/32 thick slitting saw. And I did this one off camera because I didn't expect this to work. I fully expected that the motor would stall out. This milling spindle is one that I built myself, and it has a single belt drive with an inverter, and it's designed primarily for high-speed milling. So to get saw this diameter running slow enough with enough torque to cut material is a bit difficult. Almost certainly would stall out on steel, but on this material it seems to be okay. So we'll go ahead and do this end, and then we've just got a few holes to tap, and we're done. Even that speed that that's running at is probably a little bit high, would certainly be too high for steel anyway. Did seem to cut this okay though. I should mention that this is a horizontal milling machine as well. I could put the horizontal arbor in here and set this saw up, but it means taking the head off, and it's a lot of work just for doing that one cut. So this seemed to work alright. So I'll go ahead and deburr, and then we'll tap the holes, and that part of it's finished. Just before I do tap this, I'm going to drill the clearance hole on one side of the slit, and I'm going to just lightly counterbore that as well. Just because I'm a bit worried I'm going to clamp this down, this counterbore feels a bit tight in that hole. Let's just see how we go. That's as deep as we're going to get there. This is really just for decoration. Alright, so we can go ahead and tap that now, M6. We'll do the block as well. And we're nearly done. I know I'm not going to get enough torque on this 10mm tap to complete this operation, but I got it started and started square, so that's good enough. So I'll just finish that off in the bench vise. So I've got a piece of 10mm all thread, and I've just put a screwdriver slot in this end, domed that over, and I can drive that in. I'll probably Loctite that in as well. That's going to be a permanent fixture in there. Well, here we are several hours later, and as you can see, I decided to anodize both these parts. And this was partly because the anodizing does give it a slightly harder coating on the outside, so it'll resist abrasion and bumps and knocks and so on. I found out very early on that this stuff is very, very soft, and I gripped it in the vise here and left quite a substantial divot in the back of it there. So the anodizing does toughen up that coating, but also it looks cool. So I also made the knurled wheel, which allows you to do the height setting in the lathe, and the piece of 10mm all thread just screws into the top there, and I will eventually set that with some Loctite. And this has been chemically blackened just once again to help resist corrosion, but also makes it look nice. So what we're going to do is we're going to take this over the lathe, we'll set it to height, we'll put the arm in, and we'll fit the dial indicator, and I'll show you all the shortcomings of this design. Okay, well, the original intention with the design was that you should be able to drop it onto the front dovetail of the tool post or the side dovetail and lock it up in both positions, and the arm which holds the indicator should have been able to be locked in here permanently with this pair of socket head cap screws, and you should never have to adjust it again. In practice though, it didn't work out that way. And you may recall that when I was machining this arm, I cut it short by about 3mm. In reality, that's probably not the problem. I actually made it much shorter than I should have, and it's one of those cases where I didn't mock this up properly, I didn't do enough measuring before I started, and now I'm paying the price. So the indicator should just simply slide in, and then when you tighten up this socket head cap screw, it just pinches that slot closed and the indicator's held in there firmly. And you can indicate against the face, and the idea was that you should have been able to just simply take the block off then and rotate it around to here, and as you can see, this arm gets in the way, so you sort of got to take the indicator out first, which you have to do anyway, so that's not necessarily the problem. So the indicator comes out, that now drops onto there, and I should have been able to just simply put the indicator into this hole and tighten it up. Now, because this arm is just a bit shorter than it should be, you do have to loosen these two set screws here, slide the arm along a bit and retighten them. It's all done with the same Allen key, so that's not necessarily a big deal. Tighten that up again, and we're now in business to be able to indicate on the round surface of that bar. Now, the Asperger's in me says, yeah, you screwed up, and it's sort of almost unacceptable for me. I really should make a new arm, or I could cut the arm in the center and extend it out, leave a gap in the center, but then I would need two screws. Because of where I put them, it's really not going to work. Well, that's it, I guess. Did I learn anything? Yes, I did. I should have prototyped this with, say, a 3D printed model or something like that, or I should have measured a bit more carefully. I should have thought it through. Does it mean that the thing's unusable? No, it just means you've got to keep this handy and do two extra operations, so loosening and tightening these again. I can still use it, looks pretty, does the job that I intended it to do. It's just a little bit frustrating I didn't get it right, that's all. I hope you learned something by watching this. I guess if nothing else you learn what not to do, and maybe you can do a better job than I did. I hope so anyway. Anyway, that's it for now, and thanks for watching.